Okay, let me share the screen now. Yeah, I have to reshare it with the sound, otherwise others can't hear. I think I didn't share it with the shared sound. One, yes, now hope once I started it works. Let me go to the today's session first. Yes, we will start the session. Good morning, and we will start the today's session on the today topic that I'm going to discuss is what is called the design pattern. Okay. First of all, may I know, have you learned about the design pattern in one of the previous courses in your first 2-3 years? No, you are from science faculty. Oh, UCS. All of you are UCS. You science faculty. So IES student didn't get any chance to learn anything about design pattern? Yes or no? No. Okay. Your case, no. So I have to consider all of you are kind of beginners. Okay. By the way, have you heard what is a design pattern? Have you heard this term design pattern in the past? Yes. Okay. What is that? Any idea? Objects are created. Tools. Tools to create objects. Okay, that's one way of saying some sort of a rules. Yes, people follow these rules, but there is something more than the rules that you can learn. I will discuss them. What I will do it, I have some recorded videos and I'll play that one, and time to time I stop and interact with you about the subjects, and let me the same slides I have recorded thing.
Analyze the things in a philosophical point of view uh, in software engineering and how the design patterns is. What is the design pattern? If this question is asked from you, how are you going to answer it? Okay, before answering the things, I have several sub questions. First one, is it an algorithm?
Can you hear you?
Now, if you have
No,
learned about the
there is slide.
design pattern,
Give me a
think
minute.
about
I'll get a speaker. My speaker is not there. Just give me 1 minute. I'll get that one. Until they will bring in a speaker, let me keep talking. So you can hear me then? Well, the design means, as you may remember, as I said earlier, is in finding solutions for the problem. Okay, there may be different types of the problems, different types of the issues that may occur. So in this context, when we are solving the problems, we will have to find, as you mentioned, some form of a guideline, common set of rules. If we can follow, then it's easier. If we can connect, if we can develop the solution properly. So rather than just finding a solution for a problem, if we can find a solution which is some sort of an acceptable solution, where others also recommend, then we have an assurance our solution is better than our own idea. That's the kind of an advantage if you follow the standard set of rules when developing a solution. That's the one thing. Then the other thing,
that you cannot.
Okay. So the other issue, by the way, can online group hear me when I speak here? Can you confirm?
Yes, sir, you can hear.
Yeah, great. So what the other matter that in the design process, I mean, most of the time we are finding a solution for the problem, but these solutions have already been identified by the previous people. You may have heard sometimes we call the reinventing wheel. What does it mean? It is not a new thing. People have already found, but it isn't a new thing for me. So why should we put in a big effort if the solution is already available, rather than searching and thinking and spending our time and resources? If we can directly find that solution and reutilize the solution, then it's much more easier from our point of view. So the concept behind the design pattern is it's a kind of an easier way to find the solution for the design problem. Right? And people, when they find the design problems, they document things. Okay? So that is the idea, just having that thing in mind. Let me look at my description about the open question about the design patterns. So listen to that one, small video. Okay.
In software engineering and how the design patterns is related. What is a design pattern? If this question is asked from you, how are you going to answer it? Okay, before answering the things, I have several sub-questions. First one, is it an algorithm? Now, if you have learned about the design pattern, think about whether you can answer this question. So how do you compare the algorithm and a design pattern? Can we say a design pattern is a kind of a design? What can you do with a design pattern? That's another thing. Are all patterns design patterns? Okay, so spend few minutes thinking about these 4 questions. If you can answer them in a proper way, that means you have a very good understanding and a background. Anyway, let's discuss and see. And based on my understanding, I'll try to explain it. And the discussion forum is open for you to share your comments and the feedback. Algorithm. What is an algorithm? Algorithm is usually in a precise set of steps with particular sequence, particular order. To do what? To solve a particular problem. And what is then the difference between a design pattern and algorithm? Both are known as the kind of methods to solve the problem. But can you say an algorithm is a kind of a design pattern? In an algorithm, what we see as a series of steps precisely defining what the person has to do and then solve a particular given problem. It is not an abstract. It's very kind of a concrete, what we call a specific sets of steps to solve the problem. But a design pattern usually do the same thing, but not in that way. It's in a kind of a small set of steps to solve a design problem. But algorithm we usually use for solving a low level things, a kind of a problem, especially in a programming context. You may have heard something called idioms. Okay, some people describe the idioms are kind of patterns at programming level. Okay, and try to spend some time to learn a little bit more on this one. Is it a design? My second question. What is a design? Design is a solution proposed for a particular problem. Then the design pattern, is it in a solution for a particular given problem? Well, it is not. Design pattern is kind of a small guideline people can follow to solve a problem, a particular group or particular category of a problem. However, applying the design pattern depends on the problem, its context, and several other factors. What can you do with the design pattern? That's another challenging question. Well, it's a small guideline to solve the problem. And but it's a kind of written in terms of abstract terms. Are all patterns design patterns? We usually call something a design pattern when there is a recurring aspect which is known as a pattern. And this is applied not only solving the issues in the designs, all other areas starting from analysis to the implementation, there are so many patterns. And as we can see some details later, patterns are there. So these are very good questions to start the revision about the design patterns. So let's go through the design patterns. Hope it will remind. My main reason for doing this course is the important topic about the anti-pattern, which I will discuss in the next section. Will be more meaningful, and all the people will be able to understand once we do the design pattern session first. What can you see in a design pattern? Yes, that's another the question. Very soon in the rest of the lecture you will see the more details. Introduction. Okay, how do you define? The recurring aspects of the designs are called design patterns. Recurring aspects. What comes to the mind? When I say a recurring aspects, that means again and again it occurs. If something occurs again and again, people identified there is it's a kind of a pattern. That pattern could be applied for the right context. So this pattern is could be linked with some problem. So more precisely, we call a pattern is an outline of a reusable solution to a general problem encountered in a particular context. Here you can see several important things. If I started from the end, context, problem, context and problem. What's the relationship between these two things? The most important thing, the problems are meaningful in a context. You cannot analyze a problem without talking about its context. Same problem occurring in the different context will require different solution. A general problem, what does it mean? It's not so that means we have two types of problems. One is called the specific problem, other one called general problem. General problem is an abstract problem, in other words. So there may be lots of problems which we can group them as a general problem. And then we say a pattern is an outline of a reusable solution. Okay, when I say outline of a reusable solution, it's not a specific solution. It's again the high level, like a general problem, an abstract solution. So, in other words, abstract solution for an abstract pattern in a particular context. Many of them have been systematically documented for all software developers to use. What does it mean? Systematically documented. So this is a kind of an experience, a written experience of the people who have solved some design problems, especially in the software development context. If we, by learning the patterns, we can learn lots of practices and then we can apply them. A good pattern should be as general as possible. So this is the something that will differentiate especially the algorithm and a pattern. It's a general. Algorithm is usually not general, it's a more precise. Okay. If we say in a bubble sort, it's not a sorting for anything. So some kind of a specific thing. But here the pattern are general as much as possible. Contain a solution that has been proven to effectively solve the problem in the indicated context. So a pattern is another arbitrary thing. It has been tested, tried out by the people to solve the problem. So in other words, in the simple terms, we can say it's a documented experience of some people where they have some written assurance. It's kind of an assurance. So if we use the design pattern in a right way, of course, the solution will be more stable or suitable. Studying pattern is an effective way to learn from the experience of others. So that is the what I really wanted to explain. So we lead into a context. By learning the design patterns, we learn the experience of the others. Coming to the next one, patterns, origins and history. So I'm not going to spend a lot of time, but
Okay, before going to the history, I think you may have gotten some idea what is a design pattern. In simple term, is an abstract solution. So if we wanted to say an abstract solution, that is described with respect to abstract problem. Okay, so many problems that what we encounter the specific problem. But if we carefully analyze the problem, we can make it abstract. So this problem is related to another problem. So abstract problem is actually a kind of a thing which relates to those two occurrences of a problem. So what we encounter is an occurrence of a pattern, occurrence of a problem. So if you can combine the similar problems, then you can easily identify the common problem, we could say. So if someone can write an answer for the common problem, so then that's what we call the design pattern. However, remember, when you are going to apply a design pattern to a specific occurrence of a problem, you will have to improve it or sometimes customize it or sometimes extend it with respect to the specific occurrence. Okay, that is the kind of a logic which is behind the design pattern. And there are some more things that you will come across. A problem we always describe with respect to several factors. So you will see that one little later. So before that, let's look at what is the history of the design patterns.
hope some of you may have known this person called Christoph Alexander, who is nothing to do with the software development. He's an architect. He's someone talked about the pattern concepts in the context of an architectural design. But later, almost 10 years later, these two gentlemen, Kent Beck and the Ward Cunningham, who are very famous personalities in the object-oriented concepts, in the kind of a conference, they presented something highlighting or linking with the pattern ideas within some kind of at that time very popular object-oriented programming language called the Smalltalk, which was very good for a graphical user interface design. Then Eric Gamma in his thesis around 88 to 91, where he talked lots in detail about that. Then James Copland's C++ idioms also refers a lot. At the same time, the most turning point in the literature, what you can see, this book of this group of people, okay, 4 people, it's known as Gang of Four, the Gang of Four of design patterns, elements of a reusable object-oriented software, which was presented and discussed in around 91 to 94. So many more interesting literature. So this momentum came in around 1990s, and when the people were start talking about object-oriented things, object-oriented database, object-oriented programming. So I still remember when I was in a very junior, I was a final year in my 1990s at the university, and then also junior staff member. We were also very much interested to know about the pattern and also object-oriented concepts, which was very popular at that time. Moving forward, this so many definitions you find, it's generally about the realize from original, a model, accepted, proposed, imitation. It's a dictionary term, but Alexander describes it as a problem which occurs over and over again. A problem that occurs over and over again in an environment, then describes the core of the solution to that problem in such a way that you can use this solution a million times over without ever doing it in the same way twice. So a pattern, in other words, reminds us it's kind of a tool people can use to minimize their effort. No need to reinvent the wheel again if it has already been invented. So the pattern is a guideline for us in that context in software development. He richly describes this as an abstraction from a concrete form which keeps recurring in a specific non-arbitrary context. A literary format for capturing the wisdom and experience of expert designers and communicating it to novices, is the Beck described. All these things, if you carefully analyze, talks about the same thing from a different perception, but finally trying to say the same thing. What are the properties? What are the things that you can see in the particular pattern? Pattern do provide a common vocabulary, provides a shorthand for effectively communicating complex principles, help document the software architecture, very interesting, capture the essential parts of the design in a compact form, show more than one solution. So these are the kind of benefits. These are the things that facilitate when you start practicing or trying to use the patterns. Provide a common vocabulary. What does it mean? I mean, among the different people, if they have documented a particular pattern, it's very easy to have a common understanding. People could refer it in abstract term, the name of the pattern, and then they know the type of a solution tried out. So it became a shorthand, the high level term for communicating complex principles. Document architecture, software architecture, help to document. So later we will see how the architecture could be analyzed using the different patterns. Okay, essential parts of the design in a compact form and more than one solution. At the same time, it is better to know what the patterns do not provide an exact solution. Yes, Pattern doesn't provide exact solution. So now if you can compare my first question about the algorithm, the main key thing, an algorithm, if you follow it, you get an exact solution. But here it is not. Solve all design problems? No, it doesn't solve all. It shows a one small specific thing. So patterns do not only apply for object-oriented design. That's another misconception. People think patterns are defined for object-oriented design. Of course not. So when you go into the deep, you will see the more details. If we look at in high level, I think as I mentioned in the other cases, values, principles, patterns. And we see developers, testers, end users understand the system differently. Different people see the same thing in a different way because their perspectives, their views are different. We talked about that one in detail in there. So if I try to see the pattern, if I start from the bottom, we analyze it, it's nothing but a kind of a practice which can be followed to solve the problem. So which we call a solution to recurrent designs. So this practice is defined to solve a particular problem. But if we carefully analyze, these practices could be grouped to a particular principles, and that principles are kind of a high level thing. Now for example, if I say high coupling, okay, something that should be promoted in a design, it's a kind of a principle. General design guidelines which are paradigm specific. So what is that? Values. Values are high level thing. In a software design context, we identify the non-functional attribute, okay, non-functional requirements. So we achieve these things. These values are promoted by following the principles. Practices are the thing that contribute for the principles. So you can see the bigger picture. If people wanted to promote some values or enhance some values in a particular design context, if they practice documented things under the design patterns, that will be easier. So this overall big picture, high level things, which is very similar to the many of our everyday life, and people will find it very easy to follow. The mapping could be seen.
So I just wanted to add a small thing. Design is a practice. Then these practices are based on the principles. And the principles allows us to bring values to the what we do. So always people can't concentrate what are the values, what are the principles. But the easiest way, if they follow a standard practice, which are built in, you don't want to worry about it. They are inbuilt into that one. So that is one of the big advantage of doing applying a design pattern to whenever you are solving a problem. So that's what say. So the thing is this: if you have to apply a design pattern, you should know what are the design patterns to some extent. Okay, and then whenever you encounter a problem, you know this problem will be similar to the other one, so I may be able to do it. Then you have to do an analysis and see whether it is reasonable or not. Okay, so that is the mechanism how you start applying design patterns, but the overall concept is really strong. Let's continue.
Well, two types of classification: architectural patterns and the design patterns. Architectural patterns are used for especially the architectural problems, and that's linked to the architectural principles, and the design patterns for the design principles. So the different patterns are mapped to the different sets of principles. It's not the same set of the principles. Ingredients. What you will find inside in a pattern. That could be presented as a context problem solution. Context. What is a context? A design situation giving rise to a design problem. So the background, the things, factors which are around the problem. Problem is a set of forces occurring in that context. Okay, the context is the something that give the birth to the problem. Solution is a form of a rule law that can be applied to resolve these fact forces. So in a pattern, you see all the three descriptions. It's not in a one description. It describes both the context, problem, solution, and the people will find it very easy to see this interrelationship. Placing a windows in a house, that's the context. Usually, people wanted to see what is the best place to place a window in a particular room, let's say. Well, the forces will be he wants to sit down and be comfortable based on the window, and he is drawn toward the light. Okay, if you place the window to the direction of the light, then inside the room will be have a more light. So the solution in every room makes at least the one window considering the light direction. This is the Alexander's theory in the design patterns in the architecture where he has seen. So when someone do many things, he see lots of similarities. Sometimes we don't want to recognize these similarities. If we can recognize, document, we will find ways to enhance our practices or works to achieve the final objective.
Okay, if I just added a small thing, now pattern, as I mentioned, it's a kind of a solution for a problem. But the problems are always have a relationship to the place where that problem is occurring. That is what we call the context here. Okay, and then problems need to describe with respect to the context where they have occurred. Otherwise, the description of the problem may not be meaningful. That description is very important when we really need to find a solution. Now, if I take a general life, a problem that occurs in the US, a similar problem could occur in Sri Lanka. The contexts are different. Here, it's not only a geographical location, there may be other forces which are around. So then, the same solution will not work. The solutions depends on the context where it occurs. But if you generalize the problem, that's the same problem. Okay, so that's you will understand when we are generalizing, we are always trying to generalize things by removing sometimes the context. But the issue is when you are finding a solution, we need to look at the context. Otherwise, general problems, general solutions will not work.
Pattern could be described in different ways, but a pattern template is a useful reference, and people could use to describe a pattern in a very formal way. First, context, the general situation in which the pattern applies. Then, problem, a short sentence of two. Forces, the issues or concerns to consider when solving the problem. Then the solution, the recommended way to solve the problem in the given context. Yes, recommended way to balance the forces. Anti-pattern, optional solutions that are inferior or do not work in this context. Very important thing. When we see the solution as well as the things which looks like a solution which are not really a solution, if we know the both, then it's help the people to identify the suitable solution. So the description, ideas about the anti-patterns we'll discuss in detail, but whenever we document a pattern, if we can describe or refer the anti-patterns, that will be very useful. Related patterns. Again, every solution may have some related solution. That's what we call the related patterns. So if it is possible to document, that will be also very useful. Finally, some sort of a reference will always help. So you may not be the first person to see that pattern and document. Please check out. Others may have written or identified the document or patterns almost there.
So if I say there are ways to describe a pattern, there are different ways. I mean, this is common attributes which we can use to describe a pattern. So first, before describing the problem, it's very important to describe the context. Okay, and then the problem, the specific abstract, not the specific abstract problem that you have to describe, and then forces or that are effective to the problem from the context we need to describe. And then this thing called the anti-pattern and the related pattern. Anti-pattern means most of the time when we find a solution, there may be some other things which are also looks like a solution, but the issue is they are not really the solution for the problem that we have it in on hand. They looks like a solution. So always remember this issue. Things which looks like a solution for the problem may not be a solution at all. And at the same time, related patterns, on the other hand, is not the solution, but that solution solves a close similar problem. If I say that's also happening, even in general life, we can see. I mean, if you think back, many things happening around our life in this way. Okay, and always, whenever we find a solution, we should not say, okay, this is the pattern or something like that. Always need to look at the literature. Okay, like in a research, like to see whether others have documented. How see whether your solution and how other solutions are raised up. So this is a challenging task, but that comes with the practice.
Types of the software patterns. What are the software patterns? What sort of thing? Well, in the discussion of the design patterns is patterns which are useful to find the solutions that are encountered in the software design context. Here there are several subsets: architectural design, microarchitectures, or what we call the basic general gang of four, and then idioms where we go to the low-level implementation level. And also you will find analysis patterns, recurrent reusable analysis models, organizational patterns, and the process patterns. So these things and domain specific patterns help the people to identify the right pattern, right solution to solve the problem. In this course, we will discuss in detail about the design patterns. I am not going to discuss the other patterns. However, when we analyze the design patterns, usually there are three categories, types we call it. First category is called the creational patterns. The main objective of creational patterns is to create the objects of the right class for a problem, generally when instances of several different classes are available. The next group is called the structural patterns. We are to form a large structures from individual parts, generally of the different classes. Third group is behavioral patterns. To describe the interaction between objects, they focus on how objects communicate each other. So when you look at these three patterns, three groups of patterns, they are very different. Where the first group talks about the creating the structure. So the components of the structure is the objects. So they talked about the how it works. Structural patterns are kind of a large structure. It's not the low level thing. It's a bit of a higher level thing, overall structure. And the behavioral patterns are the how dynamic situation could be described. So the problems what we will find when we analyze, we may be able to map them to the correct pattern. So let's discuss some more details. Pattern scope. Pattern scope could be described using two things. And the first one is called the object patterns, where those patterns specify the relationship between the objects in general. The purpose of an object pattern is to allow instances of a different classes to be used in the same place in a pattern at a runtime. The other one is called the class patterns. They specify the relationship between the classes and their subclasses at compile time. These two, the scope and also three categories, help us to define a two-dimensional catalog for the pattern classification. So where you see, you define the purpose of a pattern is classified into three: creational, structural, and behavior, and the scope is defined as a class and object. So there are 23 patterns you can see. These 23 patterns are related to the initial set of patterns proposed by the Gang of Four. In that book, this was documented in something around 90. Still, the proposals are very useful. The developers can use them for the different purposes. So we will see these patterns also could be a gang of 423 patterns could be identified creational, structural, or behavioral. uh, Abstract factory, adapter, bridge, builder, chain of responsibility, command, composite, decorator, wizard, factory method, flyweight, interpreter, iterator, mediator, memento, prototype, proxy, observer, singleton, state, strategy, template method, visitor. If someone knows these 23 patterns, then that will be a very good knowledge for a person to apply them whenever they solve the problem. So let's see some of the details, some of the patterns a little bit as in a revision, then you see it.
Anyway, before I go into that, I had to mention, right now, I saw somewhere people say there are around 250 documented patterns available. If you go to the pattern website, the different designers have described. This 23 is the initially what the people published as a way to introduce the design patterns. Okay, but today they are evolved. There are some patterns which are related patterns. So it's not the same solution. People say it's an extended solution for some other problem. So as people become a more experienced developers, these patterns is a very good knowledge for someone to apply a quick solution, a reliable solution. But a starting point is to learn the beginning 23 patterns. So that helps the people, okay, how it really works. So I'm not going to talk about all the design patterns in the practice, but just we'll take some of the 20. We don't have a time to go through all the 23, but you can try it. Just I will select some of the important design pattern with respect to all the three purposes. You remember the three purposes: creational, behavioral, and structural. So that's the purpose and the scope may be class object. Therefore, the whole two-dimensional classification will be there. But then we can see how these patterns, some of the examples.
Generally, the gang of four patterns can be described based on their main purpose. For example, abstract factory, we can say that it creates an instance of several families of the classes, where the builder patterns separates the object construction from its representation. Factory method, abstract factory and factory methods are two different things. Uh, they they have a two different scope also. The factory method creates an instance of a several derived classes. So it's a kind of an object pattern. Object pool is known as a wide expensive acquisition and the release of the resources by recycling objects that are no longer in use. Prototype pattern is a fully initialized instance to be copied or cloned. Singleton, a most famous pattern, a class of which only one single instance can exist. Structural gang of four are the adapter and then bridge and composite, decorator, wizard. These details are given and few more, flyweight and then proxy. So I am going to discuss some selected patterns, but not in deep. If you just search on any web, you will be able to find the full detail of all these 23 patterns, including the code samples, which will be very useful for a person to know. And whenever they encounter a similar problem in the design, these patterns definitely will help them. Chain of responsibility and the command, interpreter, iterator, mediator could be considered as some of the normal patterns that comes under the behavioral aspects. Memento, capture and the restore an object internal state. Few more, observer, state, strategy, and the template method. Kind of four categories of the behavioral patterns. Visitor.
Yeah, so I think if someone can study those 23 patterns, it gives a very good foundation for a beginner to start and see how this really works. Okay, so I will describe some of the selected of them, not all these patterns which are given there. Let's start. So then. Okay. Any question anyone has? Yeah. Are the ones that are discussed in the areas like behavioral patterns are they are the similar areas that are discussed in the subject areas like robotics. Are there specific? You mean the with respect to the domain? Yeah, I'm asking whether those are whether we are discussing the same thing. Are there any applications of no, for in this course, no, technically, if I say behavioral pattern or structural pattern or creational pattern, they may occur in a one system or one solution at the different places. Okay, application, simply an application is a collection of all these patterns. So someone can visualize a software application is a collection of a solution, small solutions. All the patterns. I mean, the patterns are usually talking about a specific problem. Okay, if I take one example, suppose in a system, you wanted to have one particular class which can create only one object, not more than that. Now, this is a simple thing. No? Suppose if you are developing a system for the UCSC, there will be a class called UCSC in that class. But you can't have more than one object called the UCSC. One and unique object should be in the system. So then you have to restrict that class can create only one object. Now, this is a very technical thing, but at the design level, if you wanted to create a class which can create a one and only one object, there must be some condition should be attached. So singleton pattern is one example. If you know the singleton pattern, you can directly put to that class UCSC because it will follow the singleton pattern and then it can create one and only one object. So structure of the UCSC class will be according to the singleton pattern. So like that, I mean, when you are developing the whole solution, this becomes a much easier. So if you know the patterns, it's like your own vocabulary. Okay, good. Thank you for asking the question. Anything else?
Anti-pattern. So here, if we look at the some details with respect to the way how anti-pattern works, the essence of the anti-pattern is two solutions instead of a problem and a solution for already designed patterns. So where the first one is the solution is in a problematic situation. So where the solution has created some issues. It is commonly occurring solution that generates overwhelmingly.
Sorry, I think I selected the wrong video. Give me a minute.
In these sections, I'm going to discuss about the details of some selected design patterns. There are 23 patterns as listed earlier under the Gang of Four are very important for those who are practicing the software engineering. These patterns are kind of good techniques people can apply whenever they do the detailed design. They will see the different problems, and then if they can match the correct pattern, then the quality of the design could be improved. Those who have experience about the design patterns as well as those who have learned about the design pattern, this will be a quick revision. I'm not going to discuss everything with respect to the selected those patterns. I'll briefly describe about the scenario of the pattern and some applications. However, if you are not sure, if you don't have any experience, or if you have not learned, I'll recommend you to search the web, and there are lots of resources about the design patterns, and better to learn those things. I'm not going to discuss about the code level implementation of these patterns, and those who have not learned about that level, better to learn a little bit, because then only you will really understand the actual use of the pattern. We may remember these patterns based on their applications. The first pattern which I selected is called the singleton pattern. It's a very famous, and most of the books it's the first pattern that is introducing. Why this is important? It is an objects creational pattern, and the intent of the single pattern is first guarantee that the class has only one instance. The other one is to provide access to that instance. This is a common problem that we encounter. Sometimes we define classes, but we wanted to control the number of objects that could be created using that class. For example, if there is a class called UCSC in a particular modeling of a system, we don't want to create more than one object because it will create a conflict within the system. So how do you restrict the number of objects that could be created with respect to a particular class? Not one object. Of course, you can extend the condition to the n number of objects. So extended version of a singleton pattern, the immediate extension version is known as a dual pattern. And you can use the same technique to n number of objects. That is possible. However, it's very important how do you do this one. We will use the template which we introduced in the previous section to describe these patterns, because that will help us to understand the pattern more clearly. Context with respect to the singleton pattern is, it is very common to find classes for which only one instance should exist. Then the problem, how do you ensure that it is never possible to create more than one instance of a singleton class? And the forces here are some of the features that you will see when you are creating the singleton pattern. The use of a public constructor cannot guarantee that no more than one instance will be created. The singleton instance must also be accessible to all classes that it requires. Having this context, if you look at the solution, well, this could be easily controlled by using the relevant method calls. So declaring the constructor as a private prevents us calling from the outsiders, but still the private method could be called by inside there. Therefore, we define another variable, a static variable, singleton, and then call the constructor. And since we make it in a static, it's made it available as in a one variable. And then usually get instance is the kind of a public call where the people will return the singleton object, the constructor object of that one, and will return outside. So this small arrangement of the constructor and the internal coding will help us to achieve that one. So it's a very simple thing. The same thing can be easily extended for more than, if you want to specify the number of objects it could be created. A dual pattern, which is very known as the next extension of the singleton. Or even it could be extended to n number of objects. So where you wanted to control the number of objects after a particular level. So the same arrangement of the code could be extended for that one. So it's a good exercise if you can try out and if you can think and see how this really works. So starting pattern is a singleton. Abstract occurrence pattern is another very simple pattern, and it's very good pattern to understand the concept of patterns. And we all know the one-to-many relationship. The one-to-many relationship is described in this pattern. The context is often in a domain model. You find in a set of related objects, occurrences, and the members of such sets share common information, but also differ from each other in important ways. So we see that in every object there are two types of data. One are specific data, other one is the common data. So how do you organize the data? How do you manage the data? We know from the practice how do we do that one. So the problem could be defined in that way, in this, what is the best way to represent such sets of occurrences in a class diagram. Forces, you want to represent the members of each set of occurrences without duplicating the common information. So if you reduce it, then immediate advantage is where you manage the data, putting the common data, and data duplication could be reduced, and the data management becomes much more easier. The solution, it's very simple, where you create two classes. In a one class, where you put all the common details. Occurrence class, you put all the other details, I mean the specific details, and link those two classes using one-to-many relationships. And that's what we usually do. We don't need a pattern. That's our common practice. So the common practice could be documented in this way as in a pattern. Many examples, as you know, that's one-to-many relationship is there. Even in a TV series, and in each episode could be described that way. And the books and each copy of the book can be modeled in that way in the library system. At the same time, the concept of anti-patterns is also very important. What is an anti-pattern? It's a similar pattern, which you may think could be used to solve the problem, but the outcome will be very bad. The outcome will be a solution which is not reliable, which will not really solve the problem in the anti-pattern. So here is an example. Rather than creating two classes, you may think, okay, put it into one class and that will become easier. Or create a small hierarchy like this with an inheritance, and you separate the data, but it's not a solution at all. It's a solution, but that will not solve the actual problem of separating the data, common data and the specific data. And there is another thing called the related pattern. Related patterns are the patterns which are similar but could be applied for an extended problem. I mean, a problem may have a different variance. Now let's see, for example, where you have a scheduled train and the specific train. So scheduled train and the specific train, where you define the relationship, and again in the same context you have a scheduled leg and specific log data that could be there. Okay, so departure time, schedule arrival time, actual departure, actual arrival time, these are linked with there. So there are two abstract occurrence patterns are linked here in this context, and that created a small structure. So if you know that thing, that will help. So this one is a very obvious thing which we do it even without thinking, but I like to highlight that this is the practice where we really need to see why we do and how do we create it. If we see the four classes are linked in this one, this is defined as an abstract occurrence square variant type of pattern. It's a kind of a special version comes at the abstract occurrence design pattern. General hierarchy pattern is another interesting small pattern which is very easy to understand. This is something what we do. The context of the pattern is the objects in the hierarchy can have one or more objects above them, what we call the superiors, and one or more objects below them, subordinates. Some objects cannot have any subordinate. I mean, this is the common case even in an organization. There are all the people are employees, they are equal, but some employees, we could say managers or supervisors, they have to control the other employees in the organization. So the problem we define here, how do you represent a hierarchy of objects in which some objects cannot have subordinates? So it's a controlling and giving the authority for some objects. The forces, you have want a flexible way of representing the hierarchy that prevents certain objects from having subordinates. All the objects have many common properties and operations. Yes, so the basic data, common operations you define and there. So here is the solution. It's very simple. You have a small hierarchy with an inheritance, but defined in a association relationship between the superclass and a subclass defined in this control structure. So then you can easily model a problem like this, where employees and the different groups of the employees, secretary, technician, manager. The manager are kind of a special group of employees where others have to work under him, so he manages. So here you define the association relationship with 0 to 1. So what does it mean? There could be managers who are not supervising any employees. That's also possible if you just put the without this um, kind of a denominator here. What would happen? That will create a kind of a conflict in the systems. So supervisors, manager supervises the employee. So 0 to 1. It's the kind of a thing. Then the same things comes here. As we know, the file system, so the files and directories. A directory is in a kind of a special file, we call it, in the which could have the files which we cannot delete, okay, usually which when it has the files, so it could have it, and so the directory contains the files, and the directory can also contains the files. Like that, a manager may also supervise other managers. There may be high level managers also, it's possible. And what is the anti-pattern in this context, in the general hierarchy pattern, where we may, rather than classifying them and creating an association, we may want to have so many subclasses. So subcategories we may define by looking at the different attributes of the different categories, and will create a huge hierarchy. That will not solve actual problem, even though it looks like a problem. That's why we call it an anti-pattern. So the hierarchy will be bigger and it will represent the organization structure, but it doesn't put the actual control what is required here. Another simple but very powerful pattern is known as a player role pattern.
I hope that you have some idea about this anti-pattern on the hierarchy pattern, where this comes with a kind of what we say. Always we need to identify the classes, not only looking at the attributes, but also the behavior. If there is no behavioral difference between the two classes, then it is meaningless to I define them as two different classes. Okay, the behavioral aspects are the key things when you are modeling a class hierarchy. So it's different from the ER diagram. Okay. ER diagram doesn't have a behavioral aspect. Yeah, the class diagram we have a behavioral aspect. So these kind of the practices will help us to create the bad structures on the other hand. So if you are trying to use the design patterns, then another advantage is that prevents you applying the principles in a wrong way. Okay. So kind of a benefit. Let's continue.
It will represent the organization structure, but it doesn't put the actual control what is required here. Another simple but very powerful pattern is known as a player role pattern. What does it mean? The player means we all play different roles in a different context. For example, I am a teacher in this class, but when I go to my office, I am a director who has to manage administrative role. It's different. When I go home, both are not important. I'll become a father, husband, son. I have 3 roles in that same context which I have to play. So the same things comes in the object-oriented modeling, where a role is a particular set of properties associated with an object in a particular context. So the role become important and defined in that context. An object may play different roles in different contexts. So we define the problem here. How do you best model players and the roles so that a player can change roles or possess multiple roles? The same person, same object could play several roles there. The forces of the player role pattern. uh, it is desirable to improve the encapsulation by capturing the information associated with each separate role in a class. So it means we wanted to put the respective details which we are important with a particular role in a when the role is active. So roles are managed where the different informations are highlighted depending on the when they become active. You want to avoid the multiple inheritance. Why? Why we want to avoid the multiple inheritance, which is considered as one of a very critical thing in object-oriented design, especially where if we can, if the same object have multiple inheritance, it becomes an unpredictable behavior, and the system will become unstable as a result of it. So that's the one of the main reason to avoid the multiple inheritance. And at the same time, you cannot allow an instance to change the class. What does it mean? Object is usually created under a particular class. So then there is some sort of an inherited set of features which we don't want to see changes. For example, if an object is created under the circle class, it should not become a rectangle. So they are two different objects, may come under the two different types of classes. So how do you manage that one? If you wanted to really create a new object, you had to create a new thing and copying the relevant details and delete one. So this is a kind of principles that we wanted to protect. So player role pattern helps us practicing these principles and also avoiding multiple inheritance and then making the relevant data active depending on the active role of the uh, player. So the solution is very simple, which we see where we create an abstract role with respect to the player, and under the abstract role the relevant roles are created. Therefore, abstract role will contain the main information which will decide the types of when the role become active, and the specific informations are maintained under these subclasses role 1, 2 and so on. So here is an example where you can see how the player role pattern is applied in a real context. Here we consider the animal class, and animals are categorized with respect to their type of food. So three groups are identified: carnivore, herbivore, omnivore, considering the three types of food, only the trees and the vegetables, though animals who eat only the leaves, vegetables, and the animals who eat only the meat, and the animals who eat both are the three groups, so based on the type of food. And then we also wanted to integrate the information of uh, animals who live on the land and the animal who lives on the water, and also there may be animals who live on the both land and the water. So how do you really model this context where you define an habitat role, where habitat role we link with an animal class using 0 to 2 uh, the relationship association. So it means an animal can have a 0. 0 means that habitat role is not defined. So if it says the 2, that means that particular animal can both live in the water as well as on the land. So That is that way. If we model it, then it becomes a more meaningful and becomes much more easier to manage this one. So here is another example where we see two roles are combined to describe the two different roles. Here the one role is here in this case students are the class. The students have a two role. One role is defined depending on their type of registration. So whether they are graduate students or undergraduate students. On the other hand, attendance roles define the way how they follow the courses, sometimes the full-time students, part-time students. And then the student object could have two roles where we describe the two roles could be active on the same context. So that's how I describe the roles becomes active in a particular context. So here is a good example where you have a multiple roles on the same context, and that will help us to manage uh, the model, the system in a more meaningful way. So whenever you encounter a problem like this, a player role pattern will be in a very good candidate solution, candidate pattern to solve that particular problem. At the same time, there are anti-patterns. That's if you know that, then will be better. The merge all the properties and the behaviors into single player class and not have a role classes at all. So that is the some kind of a thing where people may define like that, and that will obviously will create an unnecessary large number of classes on one hand, and at the same time multiple inheritance may be the only way to address those kind of a thing in some situation. Create roles as the subclasses of the player class. That's another thing people may think way to solve the problem, but of course not. Let's move to the another pattern.
I hope anti-pattern, the player role pattern is a very interesting pattern. Kind of the first good example for a complex solutions, how you can really get. I mean, if you know those things, you can easily see how these experience knowledge will be very useful when you are developing a large system. So it's a quick solution you can get. Moment you see an player issue, it's a commonly you see sometimes one particular object will have to do a lot of different behaviors, okay? And but you can't define the that object under different class. So the object has a unique identity. So, but you wanted to implement a different behavior. So how do you do it that way? At a programming level, you can do even in Java, you can implement a different behavior. So interface classes are usually be defined for that purpose. But on a design stage, if you really wanted to do this one, this is a nice technique. Yeah. Any question? Yes.
Have two roles, like being an land animal and aquatic animal at the same time, but like in such instances, we can consider if an animal, if an animal which can coexist in land and water, being in a situation where resides at land at the particular instance. But like there are some examples where we have to consider a player having both the roles playing at the same instance. For instance, for example, like in an organization, there are policies where like husband and wife cannot work at the same organization.
Yeah.
So in that case, will both the roles played by the player be applied?
That's a kind of a business rule if you wanted to apply. Okay.
Does this pattern like facilitate it?
Pattern facilitate one object to have a different roles. Now, if I say that now the example which I take it now, let's say now animal. Okay, animal we can categorize based on their the type of food they take it, and their behaviors come in. So all the animals have a type of food, so you can define. And then these animals may live on the land, may live on the water. Okay, some animals can live in both. So that means there may be some animals will have only one role, only living in a land, some animals only in the water, some animals on the boat. So then you can create a structure. But at the same time, suppose there is an animal where you have not defined their role of living. So it's still that animal exists. So later you can define that role. So that means a player role pattern allows in a way for people to add new roles to the existing class. So that is the same thing could be applied in a different application context. Now, the player role pattern can use to put some rules. Now, your earlier condition, husband and wife working in the same context. If you look at the other example which I gave it there, this files and directories. Okay, so where the files can exist under directories, not under the files. So where you put a simple rule there. So you can nicely modify that rule into this one if you want. If there is a business rule that you can bring to the design problem. Okay, yeah, fine, good. We'll continue this one. We have a few more minutes.
A kind of a very popular pattern known as an observer pattern, one of the gang of four pattern. Observer pattern is very important, especially when we develop the programs for the same data sets at different views. Context, if we describe it, when an association is created between two classes, the code of the classes becomes inseparable. If you want to reuse one class, then you also have to reuse the other. So what does it mean? So usually the classes which are related, we use the association to link. Then there is a coupling. So if something is modified, something is changed on the one class, it affects the other, and we may have to compile them. So is this good thing? Well, it is good if they are always together, but sometimes that creates unnecessary overhead. So we define the problem here. How do you reduce the interconnection between classes, especially between classes that belong to a different modules or subsystems? So that is very important when they are not in the same package, when they are on the same different cases but are linked. So how do you keep the communication? Communication formally defined using association condition. Forces. You want to maximize the flexibility of the system to greatest extent possible. So that is if you can create a loosely coupled relationship between these classes, that will help the people to manage or model the particular problem in a more meaningful way. So let's look at the solution, what we are going to do. If we really wanted to decouple the association between two classes, so in this case a concrete observable and the concrete observer are the two classes, so then what we do it, we create an abstract class called observable and create two methods, add observer, notify observer, and then we create on the other side an interface class with an update kind of a method. It's implemented here. So then create a many-to-many interaction. This will help the update will be implemented, the interface class by the observable class. So as a result, whatever the things change will be updated to all the objects which are created under the concrete observer. So here if you take an example, now usually in the weather forecasting system we have one data set and many different reports or weather viewers we call it, and if the data set changes, automatically it is updated. I mean, this is very similar to the tables and the views in the database, where If you make a modification in the tables, you don't want to physically modify the things on the views. They are automatically updated. So very similar to that. So how it really works, observable will update all the views. For example, you can create several views for one single table, and all the views will be updated automatically. So same thing happens where in the classes wise, objects wise, where you create that one using this abstract class observable and the interface class observer, where we define things. So here, those who don't know much how this was implemented, the two methods are defined, and then you have to notify it's where you implement the update, and the update will call it automatically and will get state, and get state will be um, activate on that one, so return the subject state. So here this one describes the interaction diagram showing how the flow of the messages notification goes from between those objects in abstract terms. So please go through them, it's not very difficult. We have three uh, objects, or the objects groups are defined on concrete and a concrete observer, concrete subject and concrete observer, and then the information flows in this way from one level to the other level. Anti-patterns observer, also there are several anti-patterns. Connect an observer directly to an observable so that they both have references to each other. So association, people think it's much more easier, why don't you bother in such a long way to get things done, but then it creates a problem which is not at the moment when the association is created, at a later stage as a part of the maintenance. Make the observer subclass of the observable. That's another thing people may think as a solution, but again, that's not real solution it creates. The delegation pattern, it's something one of the pattern identified that the gang of four patterns among those 23. It names implies when you say delegation, where we delegate something to some other party. So how do you really delegate? Here we looked at, it's a context. It's you are designing a method in a class. You realize that another class has a method which provides the required service. Inheritance is not appropriate because of the is a rule does not apply. So reusability is something that we always promote and we wanted to use rather than coding the same thing again and again. However, as you see the situation, if it doesn't come under the single hierarchy, so how do you really promote? So very simple problem. People do these things in different way. Here is in a proper way. We define the problem. How can you most effectively make use of a method that already exists in the other class? So how that is done? And then forces, you want to minimize the development cost by reusing the methods. That's very simple and straightforward. Where the solution, delegator, delegating method, delegate method. So here the simple thing, you create a unidirectional association from the delegator class to delegatee to get the this method call to just only to call this method. So delegating method is defined as like that. So that is the easiest way, and then this is not an association, it's only one way information. Good example is how do you combine the stack and the linked list, the two popular data structures where operations are very similar. In a stack, push is where you do all the at first, and those kind of a thing where you can simply use this unidirectional association, whereas a composition is defined, and you can do that one. And also in the delegation, if it is necessary, people can do the two-level delegation. That means that you want to use something which is not just next to the the main classes. It will be a one step away, and people could then create another delegating method on somewhere else and like this, and then call booking specific flight, regular flight, and the flight number. Flight number may define or declared under regular flight, but the booking may wants to do that one. So there you may have to go through one step to get the other one. And there are several anti-patterns that comes with the delegation. Overuse, generalization, and inherit the method that is to be reused. And also, instead of creating a single method in a delegator, that does nothing other than call a method in delegate. Consider having many different methods in the delegator call in the delegate method. And sometimes people think, why do you want to worry just creating in a one class? Why you can use the same thing for other things? Then what will happen? So then objective of the class may not be to delegation, it will be something else, and that lead to some kind of an unnecessary complication, as well as create a complexity where you will not be able to see some of the practical problems. Access to non-neighboring classes, where you can directly call that one without going through it, like where you define the method called like this. So this is sometimes people think as a shortcut to do things. Well, it may work in a programming context, but the issue is a design wise that will definitely create a problem.
Looks like my video doesn't have the sound, some sort of problem. But anyway, I'll explain the adapter pattern. So adapter pattern is another interesting pattern that comes with the kind of an problem context is you are building an inheritance hierarchy and wanted to incorporate into an existing class. And reuse the class is also often already part of its own inheritance hierarchy. So in that context, how do you obtain the power of the polymorphism when reusing a class whose methods? I hope that you may remember the polymorphism concept we discussed have the same function, but not the same signature. So it may be having a different name as other methods in the hierarchy. So this is a kind of a problem that you may encounter in a case usually. And adapter pattern usually connected with it's like now, for example, if you can't plug power socket into a kind of an adapter, what you do is you use the multi-plug or something to connect that one, which help you to connect to anything. Okay, so adapter class is something like that, the intermediate class that you create to connect with another thing, which is not directly compatible. So that is the kind of an metaphor that we have in adapter class. So probably you wanted to use this class in another method in another class, but the thing is they are not directly connected. So then intermediate class you create an adapter one, and you take that method and you connect it with this adapter, this one, that is possible. And then the same method could be used. So it's a kind of a bypassing with two classes. Yeah. So for today, I will stop for that one. I will have some more things about the design patterns, and later I will do the anti-pattern before I finish the course. But the next week, I will not do it, and Ms. Priyantini will do the lecture. And I have asked her to do a different topic, not the design pattern. And she will update all of you, and you can do that one. So So we will continue for the rest of the classes in this way. I mean, you are invited to come to the class, and at the same time, those who have a problem of coming, they can join the online. Okay. So before I finish, I may have to do one small thing. That is, wait. I'll stop sharing now. I wanted to get who are the participants. Okay. And because online people can't sign, I will mark your attendance on the attendance sheet. So I just need to look at the people who are here. So 331, I have marked. Yes. Then 577. Yes, I have marked. 585. Yes. 585. That's okay. And 722. And 722, 755. Okay, done. 798. Yes, marked. And 879. 879. Okay, I have marked online. Then comes with the 79933. 933. Okay. Then is 14308. Is 14308. I don't have. I'll write there. Maybe you can have it from here. Yes. Sorry, I think is. I have one with the 16th numbers here, but I see some 14308. Let's see those numbers here, please. Not. Okay, mark the 429. That is UCSC number, but I'll write it the numbers S 14308. Then I can see S 14451 and S 14510. Oh, these are okay. Your index numbers are here. Just a minute. I got it. Yes, 14308. Okay, online. 451. Okay. 510. Where is that one? Okay. Online and 510. 553. Where is that? 553. 552. Okay, I marked online. Yeah. I got it. All the science faculty people's numbers I marked on the other sheet. Yes, I marked science faculty one physically attended. That is S14475. And then 14308, 14501, 14451. Those are the only three things I marked. Yeah, only three people I can see from the science faculty. For the UCSC 9. Okay. So UCSC people who are marked, I just read out. They are 331. Last three digits I only say. Then 429. We have it 552. Then 577. 585. Then we have a 722. 755. 798. 879 933. Okay, those are the people who are online. I just marked that one. If you can't do it, then administration will find this in it. So that's okay. I'll sign that one. There's yes. If anyone is missing, just put it on the text, chat box. So if I didn't say, yeah, okay, fine. And today is 31 August. Okay, so we'll finish the session for today. Okay. Thank you for participating. So I'll end the meeting now.